at least two equal biggrams. The order of characters in each biggram matters. For example, the string ABA doesn't have two equal biggrams. Remember whether it's possible to make a string that satisfies these requirements. Okay, for the first one it's not possible, for the second one it's possible. Okay, first K. So what does it mean? Like, we just need to use, it's not possible. Why? Because we have AA and BB. No, sorry, AB and CC. Yeah, it's not possible. So to make the biggram, we need either three equal characters, which is fine, or we need two, right? Either 2 or on 3. So it's like we have n right. So if a dot back is greater than 2, then it's yes. If a dot size is equal to 1, then it's no. If a dot n minus 2 is greater than 1, then it is yes, otherwise no. I think this is the sufficient conditions. Yeah, to make the biggrams, if we have many characters but which are not same, then it is not possible, right? For example, we have A, B, B, C and 2D. Still it is not possible. Predominant frequency division. You are given an area consisting of integer 1 to 3. Check whether it is possible to split it into 3 contiguous non-empty parts such that for each part I from 1 to 3, the following condition: the number of elements greater than I is at most half of the parts. So check whether it is possible to split it into 3 contiguous non-empty parts. For each part I from 1 to 3, the following condition: the number of elements that are greater than I is at most half of the part. So in other words, you need to divide the array A into 3 pairwise distinct contiguous non-empty parts, so that in the left part the number of 1s is at least the total number of 2s and 3s, right? So in the middle part, the number of 1s and 2s is at least the number of 3s. In the right part, the right part can be anything, but it must be non-empty. Okay, must be contiguous. So we have many elements. So number of ones in the first part, the number of ones is at least the number of total number of 2s and 3s. So left part, ones like C1s, this must be greater than C2 plus C3, and middle part C1 plus C2 greater than or equal to C3. It's at least, right? Is at most half. And the right part, anything, it can be anything, like C1 plus C2 plus C3 should be greater than 0. It must be non-empty. That's the 3 condition we have. So okay, that means we just need to find the valid left and middle part. Count of 1 is greater. So I think whenever I get the count of 1 which is valid, the count of 1 is greater than count of 2 and 3. I think we will just try all possible ways, not necessarily all possible ways, but in a greedy way. So we check if is valid for the left part. So if a of I equal 1, then e plus is equal, then e minus is equal 1. If this is 0, then is valid of I is equal 1. Like we can make the left part up to this is possible. And after that, for each possible position when it is valid, if this is not is valid, so now it is possible or it is valid, then can we do binary search here to find this condition? Yeah, count of 2 plus count of 3 is greater than count of 1 plus count of 2. Right. So you can just use a prefix sum technique here. So we can just use a prefix sum technique. So like if a of I equal 3, then pref of I minus is equal 1, else pref of I plus is equal 1. If I, then pref of I plus is equal 1. Sorry, pref of I minus 1. This is the prefix sum we have. So to make it greater or equal, we need this set of prefixes. So insert pref of I, start erase, we need multiset. Now it will be extract pref of I. Now if st dot r begin is greater up to 2, right? Yeah, is greater or equal the current prefix of I, then it is yes. Otherwise, if no such a valid segment we can make, then it is no. So yes, no, 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 yes, no, yes, 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 no. It's giving correct answer. I think I'm good, right? Yeah. So we cannot go to the last index because we need the third part to be valid, non-empty. And here we are going up to this segment because we also need the middle part to be non-empty. So I think I'm correct. Let's just submit. Print in any case will be accepted, but they didn't provide the. Okay. Looks good. Unstable elements. You are given a sorted array of integers. We can perform any number of operations on the following type on the array. Mark the first element of the array as well as all elements that are not equal to their left neighbors. That is, mark the first element of the array as well as the all elements that are not equal to the left neighbor. So you can mark the ith if I is not equal to I, then either delete all mark element or duplicate them. That is, replace each correct marked element with two identical elements. Then you can erase or you can place. So for example, we can choose 1, we can choose 2, we can choose 4, we can choose 5. So mark them. If we delete all of them, then we are left with 1 and 4. If we replace, make duplicate, then all of them. So the operation can be performed if the array becomes. The operation cannot be performed after each operation. Every element gets unmarked. We call an array of integers be reachable if it can be obtained from the array A by some number of described operation. Your task is to count the number of reachable array of length k. Nice. Number of reachable array. So for the first element, length k, 3 into 10 to the power 5. Sum of n over 2 space doesn't exceed this, but they didn't provide any constraints on k. So for example, for 10 to the power 4 test case, k can be 3 into 10 to the power 5, and the array is sorted. There are only one possible array because all of them must be 1, and we remove the first element. This is kind of like a bunch of segment, and we can just remove one element, left element of a segment, equal segment basically. So you can just remove the left element of the segment, or you can just duplicate that or increase size of the segment by 1. Here this is 0. Yeah, 0 because every time whenever we are deleting or duplicating, the size of the array will be increased by the number of unique elements. So you can either delete or increase by 2. So you cannot make the size of the equal 4. Here, yeah, it's possible. We can then this 4 is also possible, then 6, there are 2 ways. Okay, let's see how for the 5th just case. 1 on 1, 2, 2, 2, 2. Okay, these arrays are can be obtained. Wait, I think I misunderstand the problem. You are given a sorted array this. We can perform any number of operations on the following array. Mark the first element and as well as all the elements, either delete or mark. Exception can perform if simply after each operation, then we call an array B. This can be obtained from M. Oh, so we are modifying the array A. So from the array A, what is the number of possible length B array we can, length K array we can make? We can definitely remove 1, 3, 1, and we can make 2, or we can just remove 1 and 2. So this is one possible, and it's not possible. Here we can make 1, 2, 3. It's the only possible array, and this is also 2 because we either can make 1 only with 3 elements, or we can make like we can remove 3, 1. Okay, let's try this test case. For this test case, either we can make 1 on, like in on operation, if we remove, we need 7 length. Currently we have 6 length. So if we remove again, then we have this. Sorry, 2 also gone. And then we can add like 1, 3, 3. Basically 1 on 3, 3, and 1 on 3, 3. This is a possible array, and we can make all of them 3, 3. Right? Yeah. 2 possible arrays. I feel like that there is only for this test case is no, because since all of the frequency is same, if we do remove operation, all of them will vanish, or we can just increase the length by the number of unique elements. So certainly it's 0. This is also 0, right? This is 1, because number frequency of 1 is the highest, so we can definitely make on in the final array, right? So I think we need to work with the frequencies. That's it. You just need to work with the frequencies. Okay. So to work with the frequencies, for example, we have an element with frequency 2, we have another element for frequency 3, we have another element of frequency 4, and we need to make number of such array we can make of length 5. So in on operation, each of the frequencies will decrease by 1 or increase by 1. We can decrease each of them by 1 or increase each of them by 1. If one of them becomes 0, we can never increase it again. That are the conditions. We can increase them by 1 or decrease them by 1. Basically, by some operation you can vanish this one, or you can vanish this one, right? But we cannot vanish this one because this is the most element I know. If we vanish this one, this whole array will become empty and we cannot do any operation. Right. So I think that number of arrays that we will be able to make will not exceed the number of unique elements. So I feel like that if we just store the frequencies, all of them will be less than or equal to n, and let's just use the frequency array. Then take a vector of C, let's say, if f of I is greater than 0, C dot push back f of I, and let's just sort C. Now we just need to work with C. Let's say answer is equal to 0, and then now initially, oh, we also need to input k. Now can we make I think I'll sort them this way, yeah, right, while C dot size is greater than 1 or like greater than 0 maybe, or simply C dot size. So now count is C dot size and total size is n. Total size is n. Can we make it equal to k? Difference, wait, it's only possible if n is less than or equal k. So if d mod count equal 0, answer plus is equal to 1, and C dot pop back, I feel like this is the answer. Let's see. Definitely not. For the second test case, it give us the answer which is completely wrong. 2 2. So int who is c dot back, while c dot size and c dot back equal who c dot pop back. That's what we need to do. First, second, third test case is giving wrong answer. Let's see. We have 1 1 1. K is equal also 1. So I think answer is initially 1, maybe. Wait. If we have only K is equal 1, we probably can handle this S case. Like if K is equal 1, then answer is 1. I think we will handle this S case. So if K equal 1, no, it's always not true. Always not true. But we can handle this case here. If K is equal 1, if c dot size equal 1 or c of c dot size minus 2 is not equal c dot back, then 1, otherwise it's 0. Because whenever we are removing these elements, if the last two elements are equal, which has the greatest frequency, then we cannot make 1. That's true. For the fifth test case, I don't know why it's giving wrong answer. Okay, we have 5 3. Our answer is 0. Nice. So initially we have 5 and 3. We are checking whether we can make right. Okay. This is the basically the issue is five 3. So whenever we are removing 3, we have 5. Sorry, what? We never decreasing in. removing the last element, even it's giving us 0. Again, we are not decreasing n. We are not decreasing n. Let's see now. So I think it's correct. Yeah, I think it's correct. Okay, let's just review the logic. What we are doing here, we are checking whether the count of element, like this count of element, can be an answer. So we are checking, like, if n is greater or equal, then we are checking the difference, right? We are checking the difference. Each time when we are duplicating, we are just increasing by count. So if this is divisible by count, then we are increasing the answer by 1, and we did some operation inside. What we did is this: we remove the last element, because that count of element we have done, so we must remove the last element. So we did it, and then we also removed the zeros from the last. When we didn't inside, we have to like increase by 1, decrease by 1, and check again. So I think this is correct, and this should work. Wrong answer on test 2. Okay. So why this is wrong? Let's skip this. What is the key logic like if this count is 1 and last is not equal? Then it can make this correct though. Let's just remove this because possible. Pos.pushback. I think this time it should work. Is there any S case? What is the input? I don't think there is any S case. Right. I have no idea what I did mistake in the last time, because that should correct. I don't know what I mistake. Maybe k is equal to 1 was the mistake. Anyway, 2-digit string. You are given two string A and B consisting only of digits. In our operation, you can choose two adjacent characters in either of these two string and replace them with their sum modulo 10. Consisting in our operation, you can choose two adjacent characters in either of these two string and replace them with their sum modulo 10. For example, for this string, this we can obtain this. So 5 and 7 is 12. Okay. 124, 6 for instance. And after this option, the length of this string always decrease by 1. I have a question, like if we add the last element and the summation is 0 modulo 10, then last digit will become 0. Probably you have to remove that digit. Then you can perform any number of such operation. You have to make these strings equal. You have to make these strings equal. Calculate the maximum possible length of the resulting two equal string. Okay, in either of these strings, so we can do the operation in both of these strings, and after each of the operation, on of each of their length decrease, and we need to make them equal. We have to find the maximum possible length of the resulting equal string. If we cannot make the string equal, print -1. Okay. In the first example, the maximum length can add to 61. First need to make the first digit equal. So here the first digit is 6 here and 6 here. After that, the second digit. So one of the observation is that d1 plus d2 mod 10 plus d3 and whole mod 10 is same thing is d1 plus d2 plus d3 mod 10, because that's the modular arithmetic means, right? That's the modular arithmetic property. Same, both are same, I think. So here is 5 because we can add this first two, and here is the last two. It's not possible. Now, how to find from a particular index I, what is the index j greater than I, such that sum of a of, not basically a, or whatever, say ai dot j mod 10 equal d. How to find that first? I also understand another thing, that is, for example, we match digit d up to index I and matches digit d for a up to index j for b. Do we need to like always stick on that, or we should maybe sometime we need to ignore that, or we need to find another equal string we can make further? I wonder. That will be same, so it is not necessary. For example, for a of I1 till j1 equal d, and b of, let's say, I2 till j2 equal d, and let's say we ignore that and we make another j1, let's say j1 on, which is a, let's say, d1, and b of I2, let's say j22 equal d1. I think it is same, so it is not necessary for us to combine them together, because if we subtract both of them, then we find again the equal character, so it's not necessary. For example, we have 4 4, 4 5 and also 4 5, so we have 9 and then 9, so we can keep 4 5, we do not need to necessarily skip them. And also let's say we have 4 7 and 8 5, we have 4 7 5 8, not 4 7, let's say 3 8. Okay, now we try to match the first character. We find that we can match the first two characters and make them equal, so we find like we find that 4 plus 7 is 11, so we make 1, and then we also make 1, and then we find that 8 5 also can make 13, so 3 3, so it is 4 4. If we add all of them together, 4 plus 7, this also will be same, so we do not need to split them, right? That needs to be. So I think the first condition is their summation must be equal. Their summation must be equal, otherwise it's not possible. Impossible. So we take this string s1 s2, or what they name it, I said AB, yeah, AB is easier. So first we check like the SA is equal 0, so SA plus is equal to D minus 0, int SB is equal to 0, db SB plus is equal to D minus 0. If SA is not equal to SB, then it's not possible. Good night. Otherwise we will do some checks. Maybe you can make a prefix sum modulo 10 probably. So PA of let's size equal to A of I minus 0. And then M is equal to beta size. That is B of if I, then B of I plus is equal to PB of I minus 1. So PB of I mod 10. So you find two string. Now I think we need to make two vectors, or maybe one. Let's say f of n comma 10 minus 1. Now how to find that? to find that, we can find it in several ways. Several ways, right? This is a pause of time. This will be vector. So pause of PA of I dot push back I. Pause A. Right. I think I'm making it a bit complicated, but what I want to calculate is that for a particular index, what is the next what is the next index where the sum of in range will be equal to D. So I have to calculate for each possibility. But also they consider it as a string, not a integer. So if the beginning of the element or digits are 0, that's not a problem. So need is basically something minus PA of I modulo 10. Let's say x minus PA of I is equal to D. So D is equal, we know D, so x is equal to PA plus D mod 10. PA plus D percent 10. So while f of need dot size and f of need dot back is greater than equal I, f of dot pop back. Wait, what? This is 5 into 10 to the power 3. I didn't notice that. What the hell? Shit, it is 5000. Then we can do DP probably. What the hell? Wait, if it is 5000, then yeah. Shit, it is simple DP then. Damn. It's like TP of I is equal So if wait, no, whatever, I feel like my calculation is also correct. What am I doing is also correct. What should I do? Like stick on my efficient solution or just go to a solution which we can consider DP if our greedy fail. Let's just stick right here. So if f dot need dot size is true, then f of, sorry, this is not f, pause it, then f of I of d is equal pause a of need dot back up to this position. Right, yeah, and we are going to do this for the same for the B as well. So for f, this makes us fa, let's make it fa, make it, let's make first all of the n into m, then make all of the pos a into pos b, then pb to pa to pb. Yeah, and f to fb. Now probably the db. Now probably the db. Right. So if dp of, like I say, correct, yeah, maybe we first apply this for index A. If f of fa of 0 of d is not is equal minus 1 and fb of 0 of d is not is equal minus 1, then dp of like fa of 0 of d and fb of 0 of d equal 1, right? So then we do not need to make them on this index. And then if it is not minus 1, then we are looking for, oh shit, we cannot iterate 10 times here. Already 5000 into 5000 is used. Let's calculate the complexity. So like int like 5000 into 5000 into 10. Three, 2 into 10 to the power 8. No. Although it seems like it will work, but still it has some overhead in the calculation. Let's do it. If f of I of d is not equal minus 1, if b of I of d is not equal minus 1, then dp of fa of I of d, fp of I of d equal max of fa dp of fa of I of d p of I. Nice. So first thing first, we need to check here, like debug SASB. Yeah, if they are not equal, then -1. Debug 1. That's right. Then first thing to check is this. For a particular position, debug id ffid. Everything is -1. Five, 6, 0, 7, right? So debug I comma need comma d. For 0, if we need to make 0, we need 5. And what is the pos a of that need? We have that in that position I. Okay. Are we including I? We are including. If we are including, then this must be, if I, then this, otherwise 0. Same thing going here. And then in our DP, what we are doing? Okay, wait. In our DP, we are checking from this position. We can make this. I just need to fix one of them. Like, what is the condition? From this particular index I, okay, if we are considering that from this particular index I, we need to subtract from the left, right? We need to subtract from the left. Debug I comma d of fit. First index from 0, if we want to make 0, is it possible? It's possible here. It's possible here. Can make 0 here. So need, what is need? Need is also 0. So then pause A of need. Pause A of need is giving empty. Why is this not correct? Two, right? Should be less than. What the hell? Okay, now it's correct. Okay, we're just doing the same thing here. PB, then pause B, hit B. At least giving answer. At least giving an answer. Should be +1. Like from the next index to go, right? Should probably be. Come on. Let's add 0 in the last. No, cannot. Or maybe we'll do this from here. No, it's also wrong. If the rest of them are equal, max of it's not correct. Yeah, up to this index. Yeah, up to this index. Six. Let's see. 2 and 4. Yeah. And 4, and I also want to check FA of like 2 2 1 and FB of 2 4 2 1. Four and 5. Perfect. So why it is not working? This one, and there should be 2 from after C1 2 4. T is equal to 4. So why this is not updating to? Oh shit, this is Z, I given this to I. A B of Z. Shit, man. answer is at least 1. Answer never become minus on here. So answer is at least 1. Now what I'm gonna check is that I just want to check. Okay, I just need to go through the last row basically. So for the last row, like dp of n comma I is not equal minus 1. What does it mean? That we up to I. So what is the prefix sum? Like if pb dot back minus pb of I, is it I or I minus 1? I think I minus 1, right? Because we are including I. If this is equal to 0, the dp of n comma n can be max of dp of n comma n plus 1, and same thing in the last. Six, bro, no. So wait. Taken all of them. I think I'll just make another run. If we can make any math. Oh shit. Okay. Zeros are the problem. Zeros are making problems. Okay. Zeros are making the problems. I think I am very close. So I think if like dp of ij is not equal to minus 1, this answer is equal to 1, or dp of, yeah, this answer is equal to 1. So range from I to the last. So PA I do it now. Right. So you do not need to iterate twice. We just check this. Like, yeah. Then if the range of the miracle, so int range r is equal p dot back minus p of I minus 1 0 r is equal pb dot this time it's working. So I need to check for some test case. Should I need to also I'll try to optimize this a bit more. Do we need to optimize? Yeah, because it is maybe to get to I don't know. I think I should make it global. Let's see. Let's make it a case of 3 to 1, 1 to 3, 2. Right, 3 3 3 3 is possible. So make 0 here, 0 here. Still 2. Right. So make 0 here and here. Still this is 2. Three, right. I'm going to submit it. Wrong answer on test 2. I made a DP approach, and how it can be wrong answer on test 2? Oh, answer is equal max of answer comma DP of NM probably. Sum should be equal, and then we are calculating prefix sums. Then we are prefix sums for the another array, another string. taking the immediately next index is equal. I think we need B as well. Let's say we have currently we have 5, we need 8, so we add 3. We need 3, so we add 3, so 8 minus 3 is 3, but it can be 2, right? Because 2 minus 5 is equal minus 3 plus 10 is equal 7, so it's not 2. So we need D, so it is equal something plus 10, x plus 10, so x is equal D minus, no, that's not possible. It's not possible. I think I missed some transitions. Right. Because sometimes we are only taking the minimum index. Sometimes maybe it is optimal to take the maximum or something middle index. also I think I need to do this, like if fa of I of 0 is not equal to -1, then dp of fa of I of 0 is equal max of dp of fa of I of 0 comma z definitely and 0 also. dp of ij, yeah, and if ab of I of z of 0 is not equal to -1, then dp of I of ab of z of 0 is equal to max of dp of I of z of 0. Yeah, this two transition is necessary. Now I will submit again. Like it's not the case. It's not the case. I have no idea. I need to do it faster. What I'm missing? Must be equal, right? Also, I think this is not necessary now. Answer will be what? Why? Right. This is because we need to go to log for no, wait. The problem is the problem is this. Like if I equal n, j equal n, continue, we're not going there, and only if I is not equal to n and j is not equal to m and right. I don't see any issue right now. It should work. So we need D. Like we have L and R. We need pref of R minus pref of L is equal to D. So we are searching pref of R. So this means pref of R is equal pref of L plus D. Now let's say pref of L is equal to 5, pref of R is equal to 2. So what it is giving us? It will give us like basically 2 minus 5, which is minus 3 plus 10 is 7. Now when we do this, pref of L is equal, pref of R is equal, pref of L is 5 plus 7. It's actually giving us 2. So which is correct. What we are doing is correct. We are doing plus and modulo 10. We exactly need this. Let's optimize it. But I'm not understanding what is the issue here. I'll submit it again. Since time is limited, I have to try. String AB some A, some B, or should I try mod 10? Right, I think I should try mod 10. Oh, I think this is the issue, I think. Oh shit. Shit. Bro, do not give me TLE. I think it is faster. Shit, my first. What? This is very fast. I don't know how. What is this? No way. Product of closures. Let the closures of a positive integer x is greater than 0 be the following infinite binary string. Oh my goodness, I cannot even understand this problem in 15 minutes, I think. At least this problem is kind of easy to understand. Monograph is a student as a professional, but I think like diff to f is simply harder than diff to e, so it doesn't make any sense to try f even if it is hard to understand the problem statement. Let the closure of a positive integer x is greater than 0 be the following infinite binary string c of x. Write x in binary form without leading zeros. Concatenate the obtained string with itself infinitely many times and call the result c of x. For example, c of 1 is this, c of 4 is this, c of 9 is this. Product of two closures is bitwise AND be the infinity binary string obtained by the bitwise AND string you are given 3 integer L and R among all integer in segment LR. Find 2 integer xy such that this is lexicographically smallest and print the first n binary symbol of this product. Lexicographically smallest. So we need to just find the smallest possible. Basically, we need the first index to be 0, which is never possible, right? So first digit or the first bit will always be 1. Then next bit here is 11. Okay, so basically need to find lexicographically smallest string such that bitwise XOR of lexicographically smallest string. Bitwise XOR, like two integer xy such that their bitwise XOR is lexicographically smallest. Okay, it's not hard to understand that I thought earlier. So what happened? So lexicographically XOR of two string in that range. Okay, I think it is not hard. Wait, first we will definitely try to find two integers such that their lexicographically I mean their XOR is 0. So I think that will be definitely the first integer. I think from the x and y, first x will be L. I think x will be L for 4, and then they consider it 4 and 9, and they found it. No, like 2 and 4, 2 and 4, right? Okay, yeah. Oh, sorry, it's 1 and 4, so 2 is the second element. Why they didn't take 1? Right, yeah, because ons or 4 is 5, while 2s or 4 is 6. Ons or 4 is 5. No, it's like 1 on 1 on 1, so it doesn't make sense to take 1. But for 2, second and 0, so at least it's better. So like we can quickly construct two integer problem. This will provide the best result. I have only 8 minutes to think on this problem. N is only 1000, so I think it is brute force. I think it's brute force. I'll do a brute force. 1000 into 1000 into 100. Yeah, I'll do a brute force since time is pretty low. Less than is equal minimum of plus 100 plus 100. What is the best string for this L? Next of it. just do this. If or maybe plus is the one. Why we are taking this, right? Oh shit, we have only L is basically I. Oh shit. What is happening? This is also giving correct. After that, car is not giving correct. Okay. the first one is giving wrong? Why it is 2 3, man? 2 4. Oh, that's true. It's true. If there is any 2 to the power, shit. Okay, it's not possible. Anyway, but I think if I get 20 more minutes, I probably get closer to this problem. I did very silly mistakes in this problem. Sorry, in this contest. Especially in problem D.